In this video, I am going to introduce you to MambaByte. MambaByte is a token-free SSM for modeling long byte sequences. MambaByte outperforms other byte-level models over several datasets and shows competitive results with sub-word transformers, thus serving as a promising tokenization alternative. SSMs also enable significantly fast generation due to their recurrent nature, making byte models practical. These researchers, Jinseong Wang, Tushar, and their colleagues, their findings established that the possibility of token-free language modeling in future large model is for real. Let's get a bit more into it. If you look at the experimental setup, the training criteria they followed is quite interesting. All the MambaByte models were trained using the open source Mamba code base, and at the training they shuffled the documents and used contiguous sequences of around 8192 bytes, one per document, starting from a random position. They also enabled mixed precision training using BF16 for training efficiency at scale. The optimizer, learning rate scheduler, and other training details are also available in this paper, and I'll drop the link in video's description. So they also used a sliding window to trade off speed for performance during the inference, and that is why they are using the sliding window. The results are quite interesting too if you look into that. For example, if you look at this table, this shows that the bits per byte or BPB across each dataset. So for this experiment, the MambaByte 758 million plus 262 million and MambaByte models, they used the same number of flops per byte. They observed that the MambaByte outperformed MegaByte consistently across all datasets. They also noted that they could not train MambaByte for the full 80 billion bytes due to the monetary constraints, but MambaByte outperformed MegaByte with more than 0.63 less compute and training data. Another interesting result was that MambaByte 353 million outperformed byte level transformer and perceiver AR. So if you look at it, why exactly MambaByte is performing better than much larger models, then it is quite interesting to explore, because if you look at these diagrams and numbers, this is telling you that for megabyte model of the same parameter size, models with less input patching perform better, but when compute normalized, they perform similar. In fact, a full length transformer, while slow in an absolute sense, also performed similarity to megabyte when compute normalized. In contrast, switching to the Mamba architecture significantly improves both the compute usage and the model performance. So as you can see that these are the state space models or SSMs, these Mamba based ones, and I have done various videos around them. I believe this architecture is one to look for in the future. Let me know your thoughts in the comments, and if you like the content, please consider subscribing to the channel, and if you're already subscribed, please share it among your network, as it always helps. Thank you very much.